So all of page 5 is practice of what you did on the previous page 4. Everything that you see here is just another version of a question with negative exponents or zero exponents or exponents that need to be cleaned up in some way. And the idea is mostly just to practice as many as you can. It's certainly not mandatory that you do every single question. So if you feel like you get the idea, you may find that only 1 or 2 examples may be sufficient for you to feel confident. And if you feel like you need more practice, this obviously gives you lots of different versions of things so that you can practice and practice again and practice again until you feel solid. A lot of this boils down to your own personal comfort level as it relates to your foundations. So if you came into this class with a really solid understanding of exponents, you may find that most of this is review for you, or it's very intuitive. If you came into this class having forgotten a lot of stuff about exponents, or maybe feeling like you never really learned it sufficiently in your previous classes, more practice this year may be necessary so that you can give yourself that strong foundation that you'll eventually need if you're going on to math analysis. So that's why it's kind of important for you to gauge your own understanding on page 7 here, or sorry, page 5. I misspoke, page 5. So that you can think about how much time you need to spend on this, because it's not required that you do any of the questions. It's all here for your own personal preference, and it's all here for your own self-improvement. So you decide for yourself what's best for you. I'll do in this video question numbers 9, A, and B, just to give a couple more examples. I'll go through a little bit more quickly than I was on the previous videos, just because by now, hopefully you understand why I'm doing what I'm doing and can now simply follow my logic. If you don't understand why I've done something, I suggest you go back to page 4. Go back to some of those videos and try to listen through again to the logic behind why these rules work the way they do. I'll start with number 9, letter A. You'll notice I'm using scratch paper just because I like to have a little bit of extra room. Gauge that for yourself as well. You decide. For any question that has negative exponents, I like to just draw a big fraction bar because my immediate instinct is I'm going to have to flip stuff. If I know I have negative exponents, I know stuff is going to have to flip over. Before I flip things over, though, I do like to use PEMDAS. Remember PEMDAS, the order of operations? Well, I like to use PEMDAS because that dictates to me the fact that I need to deal with this parentheses first before I can actually deal with the exponents that I have to flip over. So remember, P for parentheses, E for exponents. Parentheses should happen first when you're looking at a fresh problem. Then we'll deal with all the exponents afterwards. So let's think about the parentheses here. In the parentheses, I have 2xy all being raised to the power of negative 3. As I discussed in the previous video, the 2 has a power, the x has a power, and the y has a power. So I need to think of each of those individual powers, and I need to think of them each individually, not one lump 2xy, but instead 2 to the 1, x to the 1, and y to the 1, so that I can use that rule of exponents where I can multiply the 1 times the negative 3 for each thing, and then I can apply that rule correctly. The rule only applies when you multiply exponents times other exponents, which is why it's so crucial to notice we're not doing 2 times negative 3. We're not doing x times negative 3. We're not doing y times negative 3. Those aren't even like terms. The rule is about multiplying exponents with other exponents. The power of 1 times the power of negative 3. That's the rule that we're using. So, just to make sure it's clear, this is the first thing I'll write. On the bottom, 2 to the power of 1 times negative 3 becomes negative 3 as its new exponent. X to the power of 1 times negative 3 becomes negative 3 as its new exponent. Y to the power of 1 times negative 3 becomes negative 3 as its new exponent. So I have now gotten rid of the parentheses by multiplying the inner exponent times the outer exponent for each individual term. Now there's still a z down there, but it didn't have a parentheses around it, so I'm going to leave it as z squared. The top didn't have any parentheses, so I'm going to leave the top exactly the way it was. You could put z to the power of 1 if you want to give the z a power, just so everything looks consistent. I kind of like doing that. Giving everything an exponent helps me keep straight which ones keep and which ones flip, so that might be something important as well. Speaking of that whole keeping versus flipping thing, that's going to be my next step. Now that I don't have any parentheses to worry about, I'm going to just go term by term and ask myself which of these things needs to stay where it is because it's a positive exponent, and which of these things needs to move or flip because it has a negative exponent. So x to the negative 3, negative exponent needs to flip. Flips to the bottom, exponent becomes positive 3. I'll cross it out just to show I've already dealt with it. Y to the negative 9, negative exponent needs to flip to the bottom, becomes positive y to the 9th, and then cross it out. Z to the power of 1, positive exponent. So z does not need to flip. Z will stay on the top. The exponent will stay positive because it's already good to go the way it is. On the bottom, 2 to the negative 3 has a negative exponent. So I'm going to flip it to the top. Becomes 2 to the positive 3. Take care of that. X to the negative 3 is on the bottom, but it's negative, so I'll flip it to the top. X to the positive 3. Y to the negative 3 has a negative exponent, so it needs to flip to the top. Y to the positive 3. And z to the power of 2 has a positive exponent, so it can stay where it is. Z to the power of 2 can stay on the bottom. Now technically this is a correct answer because all of my exponents are now positive, but it doesn't match anything in this little answer bank, so I'm going to clean it up a little bit so I can find an answer in the answer bank that looks like it. If I start cleaning things up, 2 cubed, for example, on the top, 2 cubed is 8. So I can do 2 times 2 times 2 for that, and I'm just going to cross it out to show that I cleaned that up. I'm also looking for other things I can combine or clean up, like z to the 1 and z squared on the bottom. Those kind of compare. I have 1z on the top and 2 z's on the bottom, so I can essentially cross one of them out, leaving me with a single z on the bottom. That cancels the z's. Now if I look at the x's, x cubed on the top, x cubed on the bottom, that's 3x's on the top, 3x's on the bottom. Those are going to cancel out. So those are effectively all gone, because the 3x's on top would cancel the 3x's on the bottom. And then I have y cubed on the top, y to the 9th on the bottom. That means I have 9 y's on the bottom, but 3 on the top. I can cancel 3 of them out, but that would leave me with 6 leftover y's on the bottom. So y to the 6th. And now that I'm looking, I don't have any more like terms, so I'm going to look at my answer bank and ask myself, does that look like anything? And as I look at my answer bank, I can tell there is an answer with an 8 on top, and a y to the 6th and a z on the bottom. The order doesn't matter. I can clearly tell this answer, letter B, is equivalent to what I wrote on my scratch paper. So in the little box, I'm not going to try to cram my answer. I'll just write expression B and be done. Now it is important to note in the directions that it says some simplified expressions will be used more than once, so I'm not going to cross B out of the answer bank since there's no guarantee it's the only answer that matches that question. So I'm just going to write the letter B, but I'm not going to cross out. I know some of us like to cross things out in an answer bank. Wouldn't do that here. Let's try one more example just so that way you can kind of see that these questions can be more efficient. As I mentioned, I'm trying to gradually get faster and stop explaining so much. So I'll try to do letter B a little bit more to the point so that you can see in more of a real-time example how quickly you can try to apply some of these rules. Now notice in this example, I'm not going to explain my logic so much as I'm just going to do it. So just kind of keep that in mind. I'm not going to explain it, I'm just going to do it. So if you need some logic and don't understand why I'm doing things, definitely speak up. Now, you can argue that you can simplify the inside before you do the negative 2 power. You definitely could. If you want to try to do that, that's fine. I like to keep things simple, and I just want to use the 2 rules that I already know. Get rid of the parentheses, that's rule number 1, and get rid of negative exponents, that's rule number 2. So I'm going to just do what I normally do, and that's to give everything inside a power, if it doesn't already have one. So notice I just filled in little 1s where all of the exponents are that I can't see. Obviously for things that already have exponents, I'm not going to do anything with them. I just wanted to do that with problems that didn't have their own visible powers, because now I need to know what to multiply. The outside power of negative 2 is going to multiply whatever the inside power is for each term. So this 12, it has a power of 1 times negative 2, so negative 2. X has a power of negative 3 times negative 2, so that's positive 6. Y has a power of negative 2 times negative 2, positive 4. Z has a power of 1 times negative 2, negative 2. So now I'm done with the top. On the bottom, I'll do the same thing. 12 to the power of 1 times negative 2, negative 2. X to the power of 1 times negative 2, negative 2. Y to the power of negative 1 times negative 2, positive 2. Z to the power of 1 times negative 2, negative 2. So I've gotten rid of the parentheses. Now everything's all laid out. Again, it's tempting to want to clean things up, but I want to keep things consistent, so I'm going to do the 2 rules that I know I have. Take care of all the multiplied exponents. That was rule number 1. And rule number 2 will be do all of the flipping, or the negative exponents. So 12 to the negative 2, negative exponent, flip it, make the exponent positive, done. X to the 6th already has a positive exponent. Keep it on the top. Don't do anything with it. Y to the 4th, positive exponent. Keep it on the top. Don't go anywhere with it. Z to the negative 2, negative exponent. Flip it to the bottom. Done. On the bottom, 12 to the negative 2, negative exponent. Flip it to the top. X to the negative 2, negative exponent. Flip it to the top. Positive. Y to the power of positive 2, already positive. Y to the power of 2 stays on the bottom. Done. And Z to the negative 2, negative exponent, flip it, positive, done. This is looking good. Now I can clean it up. I like to clean it up now that I can see everything in its proper location. If you took a different path, that's fine. You don't have to do it the same way I did. Now, I'm going to first look for things that can really obviously save me some time and cancel. For example, z squared, z squared. Those are the same. Z squared is going to cancel the top and the bottom. So I'm just going to get rid of the z squares altogether, cancel them out, boom, done. Same thing with 12 squared. 12 squared on the top, 12 squared on the bottom, cancel out. You can think of it as 144 divided by 144. They're going to cancel each other out no matter what. So those are gone. Now if I start combining what's left over, I have 6 x's on the top and another 2 x's on the top. If I combine them together, that would be 8 x's on the top, so x to the 8th. And then if I look at y's, y to the 4th, y squared, I can cancel 2 of the y's from the top and 2 of the y's from the bottom. That would leave me with 2 y's on the top left over, y squared. And then I'll look at my answer bank. What looks like that? Looks like the only answer I can see is letter F. X to the 8th, y squared. By default, looks like it's on the top because there's nothing in the denominator. And that's true here. I didn't have anything in the denominator, so it must have been expression F that I was looking for. So hopefully, as I said at the beginning of this video, you can gauge for yourself how much practice you're going to need in order to feel confident with these problems. Now, everybody is different. Some people will just practice a couple and feel like they're fine. Some people need to practice all 8 of these examples to feel fine. I'll leave that up to you. You decide how many practice questions you need and how much time you need to help this idea sink in and make sense. In the last video on this playlist, I'll go over question number 10 and how to deal with multiple fractions in the same problem. But make sure that you're good on one single fraction problem first. That's basically number 9, before we graduate up to question number 10, which is how to deal with multiple fractions in the same question.